Okay class, in the previous lecture we have seen what is the mathematical meaning of scalar product and vector product, and we have seen how we will represent A cross B and B cross A and A dot B. We have seen the direction. Now we will see what is the physical meaning of this dot product and cross product. Why we need the dot product and cross product. I will give you a general example of your daily life. Suppose we have a car and this is, I represent the car by a box. Okay, now this is traveling along x direction with some definite velocity v, and we apply a force along the direction of velocity. In this direction we are pushing it, then what will happen? Its velocity will increase. So its velocity, let it increase by some amount. Okay, in the next case, suppose we have, this is the car and it is moving in this direction with some definite velocity v. Okay class, and we apply force in backward direction. What will happen now? The velocity will decrease v minus by some amount depending upon the amount of force you are applying. Then the third case is, this is the car, it is represented by the box C and it is moving with some definite velocity. Let the velocity is v and we apply force in perpendicular direction. Then see what will happen. In the first case, because the velocity direction of the force is along velocity, so velocity increases. Okay, and in the second case, force and velocity, these are in opposite direction, so there will be decrease in the velocity. And in the third case, velocity and the force, these two vectors are perpendicular to each other. In the third case, there will be change in direction of v without any change in its magnitude. Okay, so here the velocity will change. Okay, this is how the velocity changes continuously when the force is always perpendicular to the velocity. So if you keep the force always perpendicular to the velocity vector, then there will be change in direction of velocity without any change in its magnitude. So this is the physical meaning and of the case we have taken. Now we will apply this thing on the dot product and cross product in the coming topics. So class, we will see what is the difference between these two cases and this third case. In the first two cases, there is change in magnitude without any change in direction. Okay, and in the second case, there we have a perpendicular force which changes the direction of motion without any change in magnitude. Now we will take fourth case, which will clear the importance of dot product and cross product. Now see, let the force is in this direction. This is force, and let we have velocity component in this direction. Okay class, now this force is neither parallel to velocity nor opposite to velocity and neither perpendicular to the velocity, but we can divide, we can resolve this vector f into two components, one along velocity. Okay, so this component of the force will be F cos theta, and magnitude of the component which is perpendicular to velocity, that will be f sin theta. So in this case we have a vector force which is inclined with the velocity, and we have two components, one is f cos theta and another is f sin theta. So this component will increase the velocity and this component will change the direction of velocity without any change in magnitude of the velocity. So this is the thing which we are to apply now in this case. So here if we take these vectors velocity and force by vector A and B, like this is vector A and this is vector B, and vector A and B represent forces, then component of this component of vector B, this force in the direction of first force is b cos theta. So if you find the resultant net effect in the direction of vector A, it will be A plus b cos theta, and in this direction it will be, this is vector A and this is b sin theta. So this component will not change the magnitude of A. Because of this component of second force, there will be a turning effect in the direction of first force. This effect of these two rectangular components of B, second force, on first force, or you can take a vector of your choice, velocity or any other vector, individually. Okay, b cos theta, which is the component, let this is x direction and this is y direction. So this is x component of the second force and this is y component of the second force, that is b. Now see the first x component, x component of b. We will see its impact. I will make this diagram again. This is the direction of vector A and we have the vector B along this direction, and this angle is theta, and its component along the direction of A, that is, let be x. So this bx, this is equal to b cos theta. Okay class. So what is the meaning of scalar product? Now come to scalar product, which is written like vector A dot vector B. This is magnitude of A, then magnitude of B, and then cos theta. So what is this b cos theta? This b cos theta is nothing but component of this force along the direction of first force, that is bx, b cos theta. So what is the meaning of this? The meaning of this is, if you have a vector along x direction and you apply force in this direction, okay, then the resultant effective force along x direction get multiplied by a factor of b cos theta. This is the physical meaning. So here you will see this is magnitude of A and this is the component. This is the factor by which the magnitude of first vector get increased. So this is the meaning of scalar product. Okay, so this magnitude get multiplied. Okay, this is the product. Okay, that's why we call it scalar product. We are using the term here, product, and it is not associated with the direction. This is the magnitude. So this is a scalar quantity and the product is scalar product also. Okay, so this was the impact of X component. Now we will see the component. We have another component that is along Y direction, Y component of the second vector B, which is second force in this case. So here we have vector A, okay, and this is associated, its magnitude get increased by a factor of B cos theta. So now it is AB cos theta. Now the Y component which is acting perpendicular to it, and this is the Y component of B. Here By, this is equal to B sin theta. So this is the thing, class. Now we will see what will be the, now we have seen that what is the impact of this perpendicular component of the force. It will change the direction of A without any change in its magnitude. So due to this component there will be a turning effect, okay, and that turning effect is given by vector A cross vector B. This is equal to the product of magnitude of first vector, then magnitude of second vector, and then smaller angle of sine between them. Now we will find the direction of this turning effect. That will be from, this is the first vector in this case, and B sin theta, this is second vector. So if you curl the fingers of right hand, keeping thumb erected from first vector to second vector, then thumb will give the direction of A cross B. Let this is unit vector N, and unit vector N is perpendicular to the plane of the board. Okay students, in the coming video lectures we will discuss the properties of dot product and vector product. Okay, thank you class.